All right. So the first kind of graph we're going to be looking at is a displacement time graph. Sasha, where is another word for displacement time graph? You think you know what is another word for a displacement time graph? Is there any other words for displacement? What is displacement?
Um, S.
That's the symbol for displacement. We would say S, right? But
Yeah.
what is another word for displacement?
Distance.
Yeah. So another word for displacement time graph is distance time graph. Distance. So in a displacement time graph or a distance time graph, this is what we're doing. We are plotting. In this graph, we are plotting the displacement or distance against time. So this is what the graph will look like. So Sasha, what do you think is going to go on the y-axis? And what do you think is going to go on the x-axis? So Sasha, do you know what is the y-axis and what is the x-axis? Yeah, how do you know what those two are?
Yeah, no, it is.
Okay, what's the y-axis? This one or this one? One or two? Which one is the
So
y-axis?
the y-axis is one,
Right? So if it's a
and the x-axis is
if it's a displacement time graph or a distance time graph, right? Where am I going to put displacement? So it's displacement versus time. Where would I put the displacement on the y-axis or the x-axis? What do you think?
on the x-axis.
No, it's displacement time. So displacement here and time here. The same way this
Okay.
is y versus x. So this is a graph of y versus x. If it's displacement versus time, displacement would come here, right? So you would have displacement here. And displacement, the symbol for displacement is S, and displacement is usually measured in what? If we measure in displacement, what do we usually measure it in, Kira? Okay, I'm not hearing from Kira. Sasha, what do we usually measure displacement in?
MS.
You know what MS means, right? MS means it can mean millisecond or meter per second. When we say displacement, displacement means that you're taking an object and
Oh,
you're moving it. If I move
oh,
something, if I move something, I'm measuring what? Like if our object was over here and I move it to over here, what am I measuring there?
the distance.
Right. So what are you was the most common unit for distance? I measure distance
M.
in meters, right? On the on the x-axis we have time, and to measure time, the symbol for time is t, and I would measure time in what? What do I usually measure time in?
For seconds.
Seconds, right? That's correct.
Yeah.
So it have so I need to discuss the main parts of the graph with you all. The main parts of the graph. So a displacement time graph will most typically look like this, right? It will typically look like this. So let's try to understand what's going on here. Healy, good night. Good night, Healy.
Good night.
All right, so Healy, were you there for the last class where I introduced this topic?
No.
No? All right. Well,
Mm-mm.
you wouldn't be too lost. You know the formula for speed? Speed is equal to what?
I'm not sure.
Speed is equal to distance over time. If I ask you how fast you're going, okay, like if you're driving in a car and I ask you what's the speed of the car, what you go tell me? Give me any number.
20 miles per hour.
We're not we're not America. Give me it in kilometers. So you go say like we go in 20 or 30 kilometers per hour, right? So
Yeah.
is kilometers per hour. So what is kilometer? Kilometers is a measure of what? Is a measure of time, volume,
Distance.
distance. So kilometer per hour. You can think of and when you write it, it's be like you write it like kilometer slash hour. And this is kind of
Yeah.
look like a fraction.
Mm-hmm.
Well, it is a fraction. So kilometer is distance and hour is time. So the formula for speed is distance over time. But I introduced some new terms, some new ways to say speed and distance. Instead of saying speed, sometimes you would say velocity. Instead of saying distance, you would say displacement. Right? You okay so far?
Yeah.
All right. So if I take an object and I displace it, if I displace something, that means I take it from where it's at right now, and I displace it, I move it somewhere else. So imagine this square. This square was over here. I have a square over there, and I move it over here. By how much blocks did I move it by? How much?
5.
I moved it by 5 blocks. So that's really so displacement is just really a measure of distance, right? That makes sense, right?
Yeah.
So the same way I could have moved this block over here, and I could also take the block and put it back over here.
Yep.
But would I say that that is negative? Like if I were to measure that, would I say that's negative 5 meters long? If I have a ruler, does a ruler have negative on it?
No.
No, a ruler doesn't have negative in it. But if we do say -5, that would mean we're moving it in the opposite direction. And that would no longer be distance, that would be displacement. So that brings me on to the other thing. Displacement is a vector quantity for distance. Say understand that distance can be negative, right? We know that. A ruler
Yeah.
wouldn't have negative on it. So that's what we call a scalar quantity. It has size but it doesn't have direction. And I could take this block and move it anywhere I want. And I could either move it left or right, up or down.
Mm-hmm.
That has direction. So because it has direction, it can either be positive or negative. So I wouldn't call it distance again. I would call it displacement. I'm displacing it. So far you follow.
Okay.
Awesome. So let's look at this graph over here of displacement versus time. Let's just say, so displacement is meters. Let's just say we had a event, a track and field event. Um, Haley, how long on average is the track?
I'm not sure.
Sasha, how long the field is be that run on average? It usually be how
Like,
many meters?
wait, what?
It is usually be some meters. Like how much meters?
Like
Like the track.
50?
Yeah, look, we could say 50 is usually 100, but we could say 50. So if I write 50 over here, that's really 50 meters, right? Everybody agree? Tell me, does everybody agree?
Yeah.
Okay, And let's just say, how long you think it could take somebody to run 50 meters? Haley, how long you think it would take?
I don't know, like 5 minutes?
You said 5 minutes?
Not me, but
Nah. If we run in 50 meters is nothing. That's like nothing. You could reach 50 meters in like 5 seconds, right? Let me just say. So Haley, if I give you this information, do you think you could figure out the speed at which the guy ran? Do you think you could figure that out?
yeah,
So it took him 5 seconds to reach a distance of 50 meters. At what rate do you think he was running at? How much meters is he covering in 1 second? Sasha, see if you could figure it out. At what rate is he
One.
running at? Thelma?
The answer is 10.
Right, 10 what? Yeah, that's how many units.
10 meters.
Meters
Because
per meters
per,
per
per second.
correct. And I'll show you guys how I found it, how I found that out.
You
And
gotta divide.
yeah. But there's a little more complicated way. So let me just say that the runner reached the end in 5 seconds, right? In 5 seconds, real fast. This is Barry Allen here, flash. And when he reached the finish line, he took a little break. So Haley, if you look at this, right, this flat line, is he increasing his distance, or is it staying at 50?
they're not 50.
So if it's staying at 50, is he moving? If you're staying at a if you're not increasing your distance, are you staying one place? Yes or no?
Yeah, but you're
Yeah.
still running.
How you gonna be still running and you're not and if you're running, you're either going back to the finish line. Oh sorry, and if you're running, right? And if you're running, and you could either run away from the finish line or run towards the finish line,
Mm-hmm.
wouldn't that change the distance? Let me explain what I mean. Let me explain what I mean, right? If you start off over here and you run and you reach this point, let me just call this 0. And let me just say this is 5. This is 5 meters here. You with me?
Mm-hmm.
And then you decide to run again. And if you run again and the distance from the starting point would change, watch. If you start off over here at point A and you run, and now you're over here at B, and you run again, and now you're at point C, and every time you run, you're traveling further.
Yeah,
So if if you're not changing distance, if distance is not increasing, what does that mean? If the distance is not increasing, does it mean you're running or you're staying still? So let
you're
me say
staying still.
right, a staying still. Because from this diagram here, if you start off at A and you run, let me just say you reach B, and then from B you run again. And every time you run, you're moving further away from A.
Yeah,
So the distance is increasing. The only way for the distance not to increase is for you to stay exactly where you are. Because any direction you move, you're gonna change the distance from A. So you fully understand that.
yeah.
All right. So we need to label. So what do you think your runner is doing from 0 to 5? From 0 to 5, what do you all think he's doing? Is he staying still? Is he running? What are you doing? What do you all think your runner is doing from 0 to 5? Sasha, what do you think your runner is doing? If you had to say, is he runner? Is he running or is he staying still? 0 to 5.
he running?
Yeah, he running because and the distance is increasing. And
Yeah,
if you're running, and if you're running, and you're running away from something, any distance will increase from that.
yeah.
Yeah, right? So we're gonna write out here. So you could say we could say he's moving over here, moving. So I'm gonna say running away from start. And if you all had to say, what do you think the runner is doing over here? Haley, if he's not increasing his distance, what do you think he's doing?
He's staying still.
Yes, he's staying still. Another way to say staying still is not moving. So I'll say that. Not moving. Right? And Haley, if you have a racetrack, right? So let me just say you have a racetrack over here. And according to the graph, what do you think the distance of the racetrack is from start to finish? According to the graph here, what what distance did the runner reach? What distance? What was his maximum distance? Where did he reach? Tell me, Haley. If you look at our graph, how was he? How was the furthest the runner reached?
50 kilometers.
What's the unit here?
Oh, sorry, 50 meters.
Correct. So if this is the start and this is the finish, then the start would be 0 meters and the finish would be 50 meters. So Haley, that makes sense, right?
Yeah.
So he ran 0 to 50. How long it took him? Remind me how long it took him to run 0 to 50. Look at the graph.
Um,
Do you know how to read that or from the graph?
is it 10?
This is how you read it. So 50 will come, see we cut the graph, and that corresponds to what time? So 50 meters corresponds to what time?
5?
5, that's correct. You see that real unsure. How come?
Uh,
You
I
don't
don't
think
know.
you don't think somebody could reach 50 meters in 5 seconds?
Yeah,
Let me search it up. Um, I want that.
it just didn't seem right.
Can a human run 50 meters in 5 seconds? Yes, that's possible. It is it is extremely fast, but it could be accomplished by a human. You want to know how fast Usain Bolt was running?
What?
You want to know how fast Usain Bolt ran?
Yeah,
He ran at his top speed was 10.44 meters per second. So like very close to this. He's faster. So it is possible, right? So Haley, let me understand what's going on. So the runner, let me just say Usain Bolt. Usain Bolt is running, and at 0 seconds, he didn't start running as yet. But as he start running, the time is increasing. So at 5 seconds, he would have reached 50 meters. Do you understand that?
yeah,
And let me just say he decided to take a little rest over here. So he's taking a rest. So right now, where is he? Is he at the start or is he at the finish line?
finish line.
Right. And he has to run back. Let's just say he's a bit tired. He's a bit tired. So if he's a bit tired, do you think he'll reach the start line faster or slower than his first run?
So,
So Sasha, in the first run, how long did it take him to run the first trip? How long did it take Sasha? The 0 to 50. How long did it take him?
5 seconds.
Right? And how long how long all the thing could take him to reach from the finish to the start to make the other run?
5 seconds.
Nah, we're gonna say he got a little tired. He got a little tired.
Or like 10?
Nah, let me just okay, we could say 10. He get real tired. Right? So over here we have running away from start, not moving, and the last one, very last one will be what? If you had to say Haley, it looked like he doing what?
um,
So this over here was running away from the start or running to the finish line. Over here he not moving. What do you think he's doing over here?
running to a finish line.
Look at the situation. So this is his initial run. So that was from the start to finish, and now he's running from the finish to the
Trying to finish the start.
finish to the start. Right? Perfect. So you would say that he is running towards the well, he's running to the starting line. Or you can say he's running away from the finish line, right? Running away from finish line. So tell me if you fully understand that, Haley.
Yeah, I guess.
So let me try to figure something out here. So Haley, if it took him 0 to 5 seconds to reach 50, right? And Sasha, how long you think he rests for? How long you think he rests for?
Like 7 seconds or something.
Okay. So Sasha, if over here, right, this is his rest period. If he rested for 7 seconds, what time do you think over here would be? So at 5 seconds, he reached the finish line, and then you're saying for 7 seconds, he take a rest. So at what time did he start back running? See if you can figure that out.
Um, 12 seconds.
Hilly, do you agree?
Yeah.
Yeah, that makes sense. And if he started running at 12 seconds, what time did he reach back the starting line? Let me see if I can figure that out. All the information is here. You just have to apply it.
17 seconds.
17? Nope. I want you to look at the graph, right?
Mm-hmm.
So it took him 5 seconds to reach to the finish line. And how long is it saying it took him to reach from the finish to the start line? How long
Oh,
how long does it take him to reach back to the original place?
10 seconds.
So Haley, I want you to figure it out. If at 12 seconds he started to run again, what time would he have finished entirely? Haley?
Is it not 17?
Okay, why are they saying 17? I want to understand. Is it all there than the 5 and the 12?
Yeah.
No, the answer is 22.
The answer is 22. Haley, try to understand why the answer is 22. See if you can figure it out.
Oh, I see why.
Tell me.
Because from the finish to start, he took 10 seconds. So when you added the 12, it'll be 22.
Right, so let me look at the full graph now. Let me look at the full graph. So Haley, how long did it take the runner to reach the finish line? How long did it take him to reach the finish line?
5 seconds.
Right. How long did he relax for?
7 seconds.
Right? So 5 plus 7 is 12. And he started running at 12 seconds. And then it took him how much seconds to reach the starting line?
10.
Right. So 22. So we're fully confident there that we understand this question.
Yeah, but how like how are you so sure that he rests for 7 seconds?
Oh, that's just an assumption we make. We just assume.
Oh,
So I'm
oh,
gonna
this is an example.
yeah, this is just an example question.
Okay.
Right? I'll show you all the full working and everything that you need to do in the exam. In the exam, you have to find the gradient.
This came often in papers.
Yeah, this come all the time.
Okay.
Well, more in the older years. But you find it hard? How you find this is so far?
Not really. I find it kind of normal.
Yeah. Sasha, how you find this is?
Normal.
This makes sense though. It's not like algebra and thing that I might have a struggle for. This makes sense.
One
Sasha,
way for me to understand it faster, I just explain it in car version.
Okay, I will do that.
Sasha was boasting by the bakery today and saying that it was easy.
What was easy?
I was boasting. I say it was easy.
Kinematics.
Okay. Well, this is one of the easier things. It's one of the easier things in maths. All right. So let me show you how we would work this question out using actual maths. Because what we did, we understand it and we can work it in our head. We need to translate it in paper. First, I'm gonna write the scenario. Sasha Mohammed.
Hey, you don't need to put a government name
Okay,
out.
okay. Haley, where's your last name?
Oh, God.
Super.
Suku, right there. Sasha Suku. Nobody's gonna know that. Nobody gonna. Okay. Sasha Suku, an aspiring athlete, is attempting to beat Usain Bolt's record. She runs in a 50-meter field and takes a rest in the middle. right? So so let me just give all some time to copy this down. So the topic is displacement time or distance time graph. That's the topic. Right.
Reggie, if you could zoom in a little bit because I use my phone and I could barely see.
Oh shucks.
Yeah.
Well, I had to copy down every single thing here, every single thing. So I would advise copying this down to the side of the diagram so they could kind of understand what the diagram means. Right? Haley, what you understand better? The graph or the diagram?
A diagram.
The diagram? Right.
Yeah,
Okay, okay. Or this.
yeah.
But you can see how this makes sense, right? If you're not moving and you're not going anywhere,
You know what kind of confused me?
what
Because
can
of how the line was like, I guess, long. I thought that he was like just running in one straight line at
nah,
first.
nah. You when we doing velocity time graph, you gotta understand that better. But in this graph, since he okay, what the line means, it means that time passing, but is he changing his distance?
Mm-mm.
Mm-mm. So I have a question, right, Healy? Altogether, how much distance did he cover?
50 meters.
So you think he covered 50 meters altogether? Sasha, what do you think? How much distance do you think he covered? Well, not he, Sasha Suku. How much distance do you think Sasha Suku covered at the end of this thing? How much did she run?
22.
How much?
22.
22?
Wait,
Whoa,
wait, wait.
whoa. Healy, is
I'm
that right?
Is
confused.
it 100?
100, yes, because he had to go to the finish line, which is 50, and then he run back to the start, which is also 50, so 100.
Okay.
Sasha, 22 is the time he took. He took 22 seconds. But if I ask you how much distance he covered, Sasha, ain't he run from the start to the finish, and then from the finish to the start?
Yeah.
Yeah, so 50 and 50, 100. Wow.
You could go down a little bit so I could see the rest of the question.
Max Healy, did you copy down the diagram as well as the visualization?
I'm doing it right now.
Okay, well, we gotta wait on Healy.
Okay.
I could take a picture.
No, copy it down now. Because I know when I take pictures, I'll not go and write in my book. At least for me, yeah, when I take pictures, I think I never do anything with them. I
Okay.
just, I just forget about it. So copy it now. while you're in class. Sasha, what I'm gonna do for you is just shift it to the side so you can see everything. I guess that solves everybody's problem. Like everybody's problem. Right? Sasha, you seeing it? Are you seeing it now?
Yeah.
Cool. Keely, do you remember how to find the gradient of things? Of lines?
Yeah, I know how to do it. I just kind of forget the formula.
I will teach you it in a way you don't have to remember the formula. You can just figure it out.
That
Trust.
possible.
Eh?
That possible.
Yes, yes. A lot of things are possible in maths. A lot of things, including that.
You'll see.
So Haley, and you could have figured out his speed without any formulas, like watch. If it take him 50, okay, if it, I don't know why I keep saying that. If it take him 5 seconds to reach 50, what speed he was going at? Logically. Think about it, Haley. If it
10,
take
10
10,
meters per second.
and if we do that without any formulas, we just do that in we head, right?
Yeah.
Or so we think. Our brain is using our formula. Our brain is using our formula. In fact, and so our brain is taking 50 and dividing it by 5.
Yep.
Right? So 50 is distance over 5 time. Distance over time. It's the same concept I will teach you guys for gradient. It's the same concept.
How is Spanish going?
Uh, well, I get through the writing, the reading, the reading comprehension. It's just when you have to talk to a native, it's kind of mm, it's not the easiest thing
Mm,
in the world. You can't
mm,
really pause to think. You know, like when you're writing, you could pause to think. Can't really do that when you're talking.
I'm for real. That'll be funny.
Yeah.
I've been when we used to do forget the name of the topic and we use a lot of negative numbers. I think it was factors. I used Duolingo for math.
Oh, Duolingo have maths too.
Yeah, and I have this whole section with negative numbers and I would like be my streak was on
Okay,
fire every single day.
pop off, slay.
Yeah.
Damn, damn, nice. I hope you're copying this down. I hope you're copying this down though. Are you?
Yeah, I on my graph.
Okay, good. So Sasha, you remember the gradient formula? Be honest, eh? If you don't remember it, that's okay. We here to learn.
I don't.
So all the gradient is just how much it change, like it change in the y-axis over the change in the x-axis. So Sasha, let me make that real simple, right? Make that real simple. If I have this point over here and this point over here, as a matter of fact, Sasha, just look at it, right? At this point, what was the change over here from 0 to 50? Where's the change? 0 to 50. What's the change there? What's the difference between 0 and 50?
The distance.
No, the difference. What's the difference between 0 and 50? 50. 0 to 50 is 50.
Yeah.
If I ask you where's the difference between 8 and 10, what you go tell me?
8 to 10.
Yeah, what's the change there? What did I have to do with 8 to get 10?
Add 2.
Right, so there's a difference of 2. So the difference between 0 and 50 is 50 because 0 plus 50 is 50. What's the difference between 0 and 5?
5.
Right. So the change in y, which is 50, over the change in x, which is 5. 50 over 5. That's your answer. That's gradient. Let we just say we're trying to figure out gradient of here, right? We're trying to figure out gradient of this line. Okay. So again, is it change in y over the change in x? So Sasha, what's the difference between 0 and 50?
50.
Okay. And what's the difference between 12 and 22?
10.
Right. So 50 over 10. That's it. That's it for gradient. That's what gradient is. I'm sure you can remember that. Can you?
Yeah.
So all you're doing, you're just finding the difference here and dividing it by the difference here. Life hack day. But I will still teach you all the formula. Alright, so Haley, are you done copying and everything?
So the question.
Okay. By the end of today, we should be finished with this topic. I'll be doing past papers. So since we more or less finished the syllabus, is there anything you all would like me to review?
Is it okay if you do quadratics?
You mean quadratics?
Yeah, I said that.
No problem. I could do that. Alright, so Sasha, let me figure out the answer, at least for question one, right? What's the speed to the finish line? Right? Remember what I showed you? The difference between 0 and 50 is 50, so 50 over 5, that's 10, right? And Sasha?
Mhm.
And let me look at this one, right? So if we're trying to figure out the speed to go back. Let me ask that question, right, Sasha?
Yeah.
What is this here? This means a distance of what? What's the distance here? So the distance to run back to the finish, to the start line. How much distance is that? So what's the distance from the finish to the start?
50.
Right? And how long did it take him to reach to the finish? I mean, not the finish, the
10,
start. Tell
10
me,
seconds.
10 seconds, the answer would be 50 over 10, right?
Mm-hmm.
So let me ask that question. Is she faster than Usain Bolt? Usain Bolt his record was 10.44 meters per second. Was she faster than him? So the first one was 10 meters per second, and the second one was 5 meters per second. Did she at any point run faster than Usain Bolt? Sasha? Okay, we're not hearing Sasha. Haley, what do you think? You think she ran faster than Usain Bolt?
Mm.
In the first run, she ran at 10 meters per second, and in the second one, 5 meters per second. Usain Bolt ran at 10.44 meters per second. Did she run faster than him?
Yeah.
Yeah?
Yeah.
Tell me how she run faster than it. Tell me. So, at what speed did she run at to go to the finish line?
10 meters per second.
Is that more or less than 10.44?
Less.
Okay. On the way back to the start line, what was her speed?
5 meters per second.
Did she run at any point in time? Did she run more than 10.44 meters per second?
No.
No. So she did not run faster than Usain Bolt. How how come you say she ran faster? You're real rooting for Sasha boy. But how come you say she ran faster? What made you say that?
Oh,
Did you add the 10 on the 5?
no.
Hmm.
I was thinking that like
Mm-hmm.
5 is, how to the finish line, 5 meters per second. It's like less. So I was thinking that it's faster.
Oh my god, wait. Why are you saying, but yes, 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 that's correct, that's correct.
I'm
Okay.
correct?
Oh my, yeah, you're correct, correct.
Wow.
Because if it took him 10.44 meters per second, way boy, I can't post this on YouTube. Yes. Yeah. That makes sense because the point of a race is to finish faster. Yeah.
Doubting myself before.
Oh wait, no. I'm correct. Wait, let me
Oh,
clarify, right? Let me clarify. We are talking about speed. Okay, I'm correct. We're talking about speed, right? So, according to the record, they are saying that Usain Bolt was running 10.44 meters in 1 second. In 1 second, what will be what was our speed to the finish line? It was what? Do you remember?
10 meters per second.
So in 1 second, we was covering how much meters?
10.
Right. So he covering more distance than us in 1 second. So you talking about you
Oh,
talking about
oh,
time. You talking about
yeah.
time. So if they said that he finished in 10 seconds and if we finished in 9 seconds, then we would have been faster in that sense. Because we finished faster. We finished in less time than him. But his speed is greater than us. You understand?
Yeah.
You almost convinced me, you know. You almost convinced me. You can make a good lawyer. Yeah.
You know, I want to go Shiva Voice to do that.
Then do it. Right? You finished copying on everything?
Yeah.
Okay, cool. Let's answer the questions in a full mathematical way, in such a way that we'll get full marks. So if we want to calculate speed, so anytime we are given a displacement time graph, you find the speed using gradient. So let me write that down. In a displacement time graph, speed, speed or velocity is found by the gradient. Right. So let's answer question one first. Before we do anything, let's just write down the formula for gradient. The formula for gradient is equal to y2 minus y1, right? So Haley, going off this logic, right? If it's y2 minus y1, that's a change in y. Remember, it's a change in y over the change in x. So if we have y2 minus y1 being the change in y, what do you think the change in x would be? What do you think the change in x would be?
Um,
So y2 is the final minus the initial. So what do you think we're going to do for x? Something very similar. So we have y2 to represent the second value for y, minus y1 is the first value for y. We're going to do the same thing for x.
Um, I'm not sure.
All they're doing is just replacing the y for x now. That's all. You can do this.
Why?
So this over here is a change in y. So let me just say y was, okay, let me explain. Let me just say the first value for y1 is 5 and the second value for y is 10. And to find the difference, you go say 10 minus 5.
Mm-hmm.
And then that would be y2 minus y1 because y2 is 10 and y1 is 5.
Yeah, yeah.
Okay, if I say that x1 is 7 and x2 is 15, how would I find the difference?
X2 minus X1.
Right, see what I mean when I was telling you? It's the same thing, just x.
Okay.
Yeah, because it's y2, x2, y1, x1. Same thing. So gradient is just the change in y over the change in x. Because and when you find y2 minus y1, you're finding how much it changed by.
Mm-hmm.
Do you confidently understand that?
Yeah.
All right. So change in y. So I'm going to show you the legitimate mathematical way, and then I'm going to show you the intuitive way or you could use it for you forget the formula. Okay. For the first one is like really, really simple. Let me show you what to do. Clearly, to find gradient, you need 2 points. So this runner, he started at, what did he start at? If you had to say, did
Zero.
he started at 0, right? We would say that he started at 0, 0. Because he started at 0 seconds, and if he started at 0 seconds, he didn't move us yet. So that's 0. That's 0, 0. You understand?
Mm-hmm.
And what would be the coordinate for here?
Mm.
It's always the x value, then the y value.
Would it be
Right?
550?
5 comma 50, yes. And let's figure out some other main points. This is the point at which he started back running, so it's important. What would be this point? Sasha, what would be this point? Sasha, if you were to read off this point, what would it be?
He
This point
he
over.
ran
In case you wasn't paying attention, this point over here is 5 comma 50. 5 comma 50. What do you think this point would be?
12,50.
Yes. Right, and I need somebody to tell me what this point is. This is the point at which he finished the race. Wait, this is also an important point. So Haley, when he reaches back at the starting line, the time would have been what? What would the time have been on the stopwatch?
22 seconds.
Right, that's all we know for sure. 22. And since he back at the starting line, and he's back at the 0 point,
Yeah.
yeah, so 22 comma 0. We good?
Yeah.
Oh, okay. So doing this in mathematical proper way. So we have the points 0 comma 0, and we have the point 0 comma, sorry, 5 comma 50. Right? Haley, I needed to pick a point, right? So here what? Haley, which point is your initial point, like your starting off point?
0, 0.
Right, so we're gonna label this x1, y1. How do you think we're gonna label this?
X2, Y2.
Correct. Now, if we're thinking about this, um, I'm not gonna call it the gradient, right? We know for a displacement time graph, you use gradient to find the speed. So I'm gonna call it the speed. So to figure out the speed, it's going to be y2 minus y1. Y2 is 50 minus y1 is 0 all over x2 minus x1, which is 0, right? And Haley, what is 50 minus 0?
50.
What's 5 minus 0?
5.
Right, so it's 50 over 5.
10.
Right, so the answer is 10 meters per second. You understand that?
Yeah.
Cool. Let's do question 2 now. So with question 2, we have the points 12, 50. We have the points 12, comma 50, right? And we have 22, comma 0. Which one you want to call the starting point?
1250.
Okay. What if I tell you it didn't matter what your starting point was, you'll still get the same answer? You would be mind blown. Be like, huh? Yeah, maths is kind of cool.
That's not true.
You will get the same answer. Let me show you. So if, let me just say I swap this, right? Let's just say I swap. Wait, you said maths is not cool. That's that. I said maths is cool,
No.
but that's not true. Oh,
Well, test and I'll determine if it's true or not.
so what you were saying is not true. Maths is cool, or you don't think you'll get the same answer?
I don't think you'll get the same answer.
Well, let me see. Let me see, right? We can try it here. Let me try this first. So we're saying that the speed here, the speed would be equal to y2. Y2 is 0 minus y1, which is 50, all over x2. X2 is 22 minus x1 is 12. So we have 0 minus 50. Sasha, what is 0 minus 50?
50.
No, minus 50. That's minus 50.
Oh, minus 50.
And what is 22 minus 12?
And
10.
10, that's 10. Hmm? Now here what? We can't call that speed because speed isn't negative. In a car, right? I'll either see negative meters, I'll either see negative kilometers per hour.
no,
No. So it's really velocity. Velocity is the vector quantity for speed. So think of velocity, but just like a better version of speed. Velocity is do the same thing speed is do, but it has direction. And let me explain. Haley, if you look at the man running, well, Sasha, if you look at Sasha running, right? Sasha is not a man by definition, right? Yeah, Haley. If we moving over here, so that would be 10 meters per second, right? And that's 10 meters per second.
mm,
But
yeah,
that's 10 meters per second in this direction. If I go in the opposite direction and I'm moving in the other direction, obviously,
yeah,
so the velocity for that would be negative because velocity is a vector quantity and that has direction. So here what guys, just to be safe, when you're doing these questions, don't call it speed, call it velocity. But in all your head, just know velocity is like a better version of speed and they kind of mean the same thing, right? The only difference is, Hilly, can you have negative speed?
no,
No, but you could have negative velocity. So your final answer will be negative 5 meters per second. And that just means you're going in the other direction at 5 meters per second, right? Because it was going towards the starting line. So Haley, you were saying you don't think it will work out if we switch it.
mm-mm,
Okay. You doubting, ma?
yeah,
Okay. So we're gonna call this x2, y2, We're gonna call this x1, y1, right? Okay, let me see. So again, it's y2 minus y1. So that'll be 50 minus 0. And what should I put in the bottom? X2 minus x1.
12 minus 22.
Right. What is 50 minus 0?
50
Okay. What is 12 minus 22?
minus 10.
Was that positive divided by a negative?
A negative.
Right? So you get back in negative 5.
Would this work in all cases?
All cases, every single one. This would it don't matter, right? Because all gradient is the change in y over the change in x. So now we're gonna show you the way you could use it if you forget the formula in the exam. Now this is still the formula, it's just like a shortcut version, right? I know they like all the shortcuts. Because here what? I rather only get like 2 marks than lose 3 marks. You know? Yeah, right? So shortcuts. Let me show you how this working. So Haley, I want you to look. So we have this graph over here, right? We have this graph over here, right?
Yeah.
We have we have height. This graph has a height, it's 50, and it has a length. Length is 5. That's real simple, right? So
Mhm.
again, intercept is the change in y over the change in x. I said that, right? I said it was the
Yeah.
change in y over the change in x. How much did the y change by? We're going from 0 to 50. How much did it change by? How much did it change by? What's the difference between 0 and 50?
50.
Right, 50. What's the difference between 0 and 5?
5.
5. So you're just simply going to put 50 over 5. That's it, right? Velocity equal to 50 over 5, right? Pay your answer to meters per second. That's it. Right, now Haley, let me show you how you would do the other one. Okay, so it's the same concept. What is the height of this? What is the y value for that line? So like, this is what I mean. What's the y value for that? If we go across on the y-axis, what's the difference between 0 and 50? What is the
Um,
difference between 0 and 50?
50
50. And what is the difference if we look at the x component? What's the difference between 12 and 22?
minus 10. Oh,
That's
sorry,
10.
10.
Minus 10, right? Because 12 minus 22 is 10, right? And that's it.
Yeah.
50 over minus 10. That was real easy, right?
Yeah.
Maths is easy. So the velocity is equal to 50 over minus 10. Yeah, I'm gonna show you that one more time.
Mhm.
Huh?
Sure.
Okay. So what you're gonna do is, so obviously this is a slant line, right? Slant line. And you could agree it have a vertical component, which is the y, and a horizontal component, the x.
Yeah.
So we're looking at a change in y. How much is it changing by on the y-axis? 0 to 50.
50.
And how much is it changing by on the y-axis? I mean the x-axis.
5.
Okay, so 50 over 5. That's it. If we look at this line, what is the horizontal component there is 10. It changes by 10, and the vertical component changes by 50. So 50 over negative 10. Understand, right?
Yeah.
Cool. Sasha, do you understand? Sasha, I think I would have explained
Yeah.
this to you before, but you understand?
Yeah.
Okay, cool. So Sasha, did she run faster than Usain Bolt?
No.
No, because Usain Bolt ran at, how much did he run at?
10.44.
Is that less or more than 10?
That was more than 10.
Right, so he ran faster. So we had to say no, right? No, she did not run faster, right? And the reason for this is because 10.44 meters per second is more than 10 meters per second, right? And another question they could ask you to find the average velocity. What is the average velocity? Okay, so let me show you how we would find that, right? So Haley, remind me, what was the formula for speed or velocity again?
Um,
So if we're talking about speed, we know is what over what? Oh, right. If it is speed we're finding for, what's the formula again? Remind me.
that's all.
Think, no, don't look back. I don't want you to look back. Think about where you remember, like if you're in a car and I ask you the speed, you go tell me kilometers per hour, right?
Yeah.
Kilometers is what? What we measure in there? What do we measure in kilometers?
Me- Meters? Distance? Sorry.
Distance. It wouldn't say meters, right? Kilometers, we measure distance, and hour is
Sec second?
no. Hours is not seconds. Hours is our measure of
Time?
time, right? So we have kilometers per hour, which means distance over time. That's the formula for speed. Distance over time. Anytime you forget, just think about kilometers per hour.
Okay.
Kilometers is distance, right? Hours is time. But we are a little more fancy over here. So if you want, you could say displacement over time, right? If you want.
Okay.
But we just a little maths. Real simple here. So if you want to figure out velocity, you can say total distance. You could say this, you could say total distance over total time. Over total time. Or you could say total displacement over total time. Sasha, you could just remind me, what was the full distance she covered? What was the full time she took?
22.
Yes. Well, that's the time. And what is the total distance? What is the total distance?
50.
No, that's not true.
Or 100.
100, yes. Right? Guys, just remind me, where's another word for velocity? Or are they doing maths? So where's another word for velocity?
Speed.
Yeah, velocity and speed. In maths, they use it interchangeably, although it's not the same thing. Right. So, Haley, what was the total distance that she covered? What was the total distance? Remember,
50.
she ran towards the finish line and then she ran back.
Uh, 100. 100.
100. So that would be 100. 100. And what was the total time it took her?
22
Right.
seconds.
So where's 100 divided by 22?
As um 4.54
4. Where's the units? 4.54 what?
meters per second.
Correct. Because it's distance over time. Right? And that's basically all the questions they would ask you for this topic. Well, for displacement distance time graph, right? The next kind of graph is velocity time graph, and that graph deals with acceleration. It's a bit more complicated, but we're done with this, so I can give you all questions on this type of graph. So I would like you all to put down the work in. Healy and Sasha, how long do you all think it would take to copy this down? How much time do you all need?
Like 7 minutes.
Okay,
5, 6.
7 minutes on the clock. Run it. All right. Did you all copy down the work in on the screen?
Yeah, I reached my shortcuts.
Okay, cool. So would you like me to scroll down?
Yeah,
Okay.
please.
Okay, Sasha, do you have everything copied down?
I finished.
Sasha, are you still with us?
Me.
Okay.
Yeah.
All right, Sasha, you just let me know when you finish copy down, right? Sasha?
Yeah.
Okay.
Finish.
Okay, cool. Time to give all this some questions to do. Right. All right, I want to let you try this question here. All right, so give me like 10 minutes. Begin. All right, so any troubles are they having, just let me know. But try to figure it out.
Which year this is?
I can't say the year, I'm not sure.
The Car City. Yeah, I wanted to find it in my book.
I'm not sure what the year is. Like, I've been honest. Like, I don't know. Right? Copy down the question and try to do it.
I have a question.
Yeah.
Since the time in hours, do we change it to minutes?
No, you don't change it.
Okay,
Don't
so
say-
when I'm writing like um kilometers, do I put kilometers per second? So
Okay. Everything you do has to make sense. Do you see seconds in this question?
no,
So
that's
let me
not
so um in 12, okay, in how much, again, like it's hours, right? In how much hours did it take to travel 12 kilometers?
two.
Right. So it'll be per hour. So if
Okay,
it take you 2 hours to reach 12 kilometers, how much it would take you to reach, how much hours it would take? Well, I should really ask, how much you could travel in 1 hour? So if you travel 12 kilometers in two, how much you could travel in one?
6,
Right. So the average speed would have been
6 kilometers per hour.
correct, because in 1 hour you reach 6 kilometers. Nice. What did the athlete do between 2 and 3 hours after the start of the journey? So what do you think the athlete is doing between 2 to 3 hours?
Moving.
Yeah, not moving. Could be resting. And why you say that? Why you say that the athlete wasn't moving?
Around.
Is the distance increasing?
No,
No, he's not moving. He's staying at what distance from the start line?
he's staying at 12 kilometers.
Away from the starting line. Nice. Right. Are you guys getting through? Keely, are you getting through with part three? They're asking what is the average speed on the return journey?
Yeah, I sent you my answer.
Oh, okay. I didn't get anything on WhatsApp. Okay, I now get it. Let me check it out. Okay, the last one is wrong. Okay, so Haley, big part here, right? In part three, are they asking us to find the average speed of the whole journey?
Oh, no.
No, the return journey. Can you show me where the return journey is? This
Um,
is, tell me, which portion is the return journey? A, wait, is it A to B, B to C, or C to D?
C to D.
Right. So if we're looking at this, how long did it take to go from this point to this point? Ah, that's the question.
Mm.
What do you think this would be? It's
Oh,
between 3 and 4. So what do you think this would be?
is it a hour and a half?
Oh, and a half. Yes, that's correct.
Okay,
So this would be what? It's between 3 and 4. So that'll be,
3.5.
right? So that'll be 3.5. So it's between 3.5 and 5. And the change in time there, that would be 3.5. The difference there is 1.5. So it was correct. So it's really 12 over 1.5. That's what you have in mind?
Yeah.
Cool. Cool. Excellent. I like the statements and everything you did. Great. Right? Sasha, Kiara, Kirsten, waiting on answers. I'm waiting.
Only last question.
Okay. Time finish. Take 2 more minutes and wrap up. Okay, Kirsten, no problem. Um, Kiara, did you finish the question?
I'm on the last one right now.
Okay. Haley, you're feeling good about yourself.
Somewhat. Yeah.
You get through the whole thing, right? So what was the answer you got for the last one? It's supposed to be 12 over 1.5, right? What did you get?
Um, 8
Okay.
um
Yes.
kilometers per hour.
Right.
Sorry.
You okay?
Yeah, I just pulled them back, of course.
Oh, okay, okay. Cough, cough. Have you coughed yet?
Yeah, sorry.
Okay, that's good. That's cool. Glad they coughed. Right? Um, so in which journey in where is it?
I said I sent you.
Okay. So sorry, someone vexed you. It's like, I said it. Wow, you alright? You're good or what? What are you talking so for?
I know, Mal.
Okay, okay, if you say so. I'll check your answer. Okay, so for Sasha, for part two, just say the athlete rest. Because they ask us between 2 to 3. Oh, you said 1.5? 2 to 3 point. Yeah, that's correct. Okay, okay, yeah, yeah. Yes, Sasha, that's correct. Good job.
Okay.
Don't just put H, I put HR. Put HR. And you had to say the athlete took a rest. You can't just say the athlete rest for a time. Actually, the athlete rest for it's talking out weird. The athlete rest for a time of you should just say the athlete rest for 1.5 hours. It don't have rested
Okay.
is not a word. Rested is not a word. Is it? I remember when I was in school, rested wasn't a word, but you should probably say that. You should say the athlete rested for 1.5 hours. That sounds better. So
Okay.
you good to go. I just waiting on Kiara. Kiara not doing the work. Yeah.
I just do the last part wrong, so I had to do it over.
Oh, okay. Well, I hear pages Russell just now, so I'm gonna assume you did do it, right? Gonna assume you did do it. So I'm gonna do the corrections now. Then I'm gonna give you our next question, and that'll be it for class today. Next class we'll do velocity time graphs and just do past papers, and we'll be done. We'll be done with this. So Haley, let's correct this really fast. So we need to figure out the average speed for the first 2 hours, right?
Mhm.
So so the speed would be equal to the distance over the time. If you look at the graph,
Just now. Hold on.
okay,
Sorry, go ahead.
yeah. How long did it take the? Okay, so we have 12 and 2, right? So the runner would have run for 2 hours and then stop. So in 2 hours, he ran a distance of 12 kilometers. So we're gonna write 12 over 2, right? 12 over 2. And 12 over 2, as we know it is 6. And it's distance over time, so it's kilometers per hour. Really simple. Part 2, what did the athlete do between 2 and 3 hours after the start of the journey? The athlete rested. It rested. Right? What was the average speed on the return journey? Again, speed is equal to distance over time. On the return journey, on the return journey, which is this piece over here, right? On the return journey, guys, he covered 12 kilometers again. As you can see by the y-axis, that's definitely 12 kilometers, and it took him how much? Much time? Sasha, how
How
long
long?
did it take him? What's the difference between 5 and, well, this is 3.5.
2.5.
No, 1.5. Because 1 plus 3 is 4, and any point 5 is 1 again, so 4 plus 1 is 5. 1.5.
Yeah.
So the distance Distance is 12. The time is 1.5. The answer is 8 kilometers per hour. 8 kilometers per hour. And I'm going to add some additional questions. Okay, let's go. First additional question I'm going to ask. What was the total distance Yeah, I want somebody to tell me that. What was the total distance the athlete ran? What was the total distance? Could anybody tell me? What was the total distance?
Is it 24 kilometers?
That's correct. You didn't get a catch. Can you explain to everyone why you said 24, not 12?
Because he had to move from um the starting point to the finish line and from the finish line back to the starting point. So it would be like he's running twice.
Okay, he is running twice. Yeah, so the distance doubles. Right, the answer is 24 kilometers. Hey, but that's the real distance to cover. 24 kilometers. And what was the average? What was the average speed of the entire journey? Right? So if we want to figure out the average speed, that would be equal to the total distance all over the total time. So what is the total distance? Again, the total distance is 24. And Sasha, what was the total time it took to complete this journey? Sasha, what was the total time it took to complete this entire journey? Fast. We stalling here. All right, Haley, tell me, what was the total time of this journey?
5 hours.
5 hours.
Yes, it was 5 hours, right? 5 hours. What is 24 over 5?
4.8.
Right, 4.8 kilometers per hour.
Hour.
Nice. So you all could, well, everybody have the question correct, right? You all have that exact working. You could just add in the additional part. Kirsten, I'm gonna send you working on your chat. It's real cute. Real nice. Check Kirsten's working now. She draw like a little bow and thing. Real cute. I still didn't get anything from Kira. Wait, Kira.
Okay, my working kind of messy. I'm gonna send it to you now. I was going to send it to you, but then I ended up doing it on the board. My working really scrappy, so you have to ignore it, okay? I don't have a bow on my answers.
Okay, okay. Keely, where you get Pomerock from? Out of here.
My POB teacher, he's the best.
Oh.
Yeah.
Kira didn't really just put a piece of sticky note over her answer. That's wild.
It not over my answer. That was the thing I did do wrong.
Okay, if you wanted to find the gradient, you're supposed to take 2 points, right? So you're supposed to take, so like, with the method we didn't use gradients because the gradients would just be overcomplicating it. What we did was,
Because I realized that because here what I do, right? I use the 12 and then the 0, right? Because I don't know what I tried to do. And then I still end up getting the 12 and the 1.5, right? But it wasn't correct mathematically. So,
so if you wanted to use gradient, you're supposed to label all those points, right? This one would be x1, y1, this one would be x2, y2,
yeah.
x1, y1, so on and so forth. But the answer you'll get for this would be negative, and it would be negative, right? So that would be more velocity than speed.
It was negative, and that's when I realized I do it wrong.
You didn't do it wrong. You didn't do it wrong, right? You didn't do it wrong. The velocity is negative 8 kilometers per hour, but the speed is 8 kilometers per hour. You didn't do it wrong. If you do it that way, you'll get it correct. But this was just the simplest route, right? You're not making your life any more complicated here, just making your life real simple. Heliant, we like to make our lives really simple.
Yeah. Shortcut on top.
Yeah. Kira, why does that Loki look like you? I can imagine.
SpongeBob sticker.
Yeah. Damn. So here what? I have a quiz to do, and it finishing 12 o'clock in exam. I had to do it before 12. So since it's 8:58 already, I'll give you all a question for homework, and you all will do that. I trust that you all will do it, right? Healy, and we're very dedicated to the maths,
Of course.
right? I don't know. I'm to Amy. Amy not even in class today. What is this? I'll just say something to Amy in your recording. Say something.
Amy, you
Hi,
need to
Amy.
pass. Hi, Amy.
Nah, all I had to be like, wow, Amy, it's supposed to be in class. What is this?
Yeah, Mom, Amy, why are you being a delinquent?
Whoa.
Join class right now.
Wait there, Amy. You're missing out classes.
It's how Kira say it. Kira say it with real gusto. She said it with real passion. Hmm. Kira,
Tasha, sound like a sweetheart.
yeah, but Kira sound like she have something against Amy.
I
It-
don't. I don't. Amy is my. She's my friend. She's the sweetest.
That's good. That's good. All they don't have anything against each other. That's good. Anywho, that's it for class today, right? Keely, this
Wait,
topic easy,
Yeah.
really,
Amazing.
real easy, right? So like easy 5 marks, the easiest 5 marks ever,
For
right?
real.
So yeah,
Hopefully it come.
now let me pray it come, right? Let me pray it come. This how to come, please. I think this come this year in 2025 January, you know.
For
Think
real?
yeah, let me check. 2025. Did I import it? Let me check it out. Did it come? Hmm. Come now. Okay, it looking like it didn't come. Wait. Oh no, it did come. Watch. But
Oh my God.
but it was a velocity time graph, which is what we're gonna cover next class, right?
Oh,
But it was with two 6 marks. Yeah, right? So cool, right? We can get that. So hope all you have a blessed night. Take care, everybody. Later.
Rajiv,
you
Yes,
Rajiv,
too.
Sasha.
Bye.
you coming home tomorrow or nah?
Yeah, coming home tomorrow.
Okay.
Yeah. All right. Well, later, everybody. Have a good night.
Bye. See you soon.
Thank
Yeah.
you.